So in the last video, I mentioned that we want to replace this vector class with the array list class. Let me just give you a little background on what that's about. So actually, if you're looking at NetBeans and Eclipse will tell you something similar. It says here, vector is an obsolete collection. And if you look at the documentation for vector, towards the end, it says here, as of the Java 2 platform version 1.2, this class was retrofitted to implement the list interface. We'll briefly touch on that in a second, making it a member of the Java Collections framework. Unlike the new collection implementations, vector is synchronized. For this course, we're not going to be doing any stuff with threads or anything like that, so you won't have to worry about synchronization. So if a thread-safe implementation is not needed, which we don't need, it's recommended to use array list in place of vector. So that's what that's about. We're going to use array list. Now, as far as the list interface, remember we mentioned earlier that in our program, Java's in our program, the vector object is using these methods like remove all elements, add element, element at, which array list doesn't use. Array list uses clear to remove all the elements. It uses get to get a particular element instead of element at. It uses add instead of add element. The list interface basically is gives a set of method headers that need to be used by all the classes that share this interface. So what that means is that so like this add we saw and clear that array list has, and get that array list has. So since array list implements the list interface, array list has to have all of those. But also, as was mentioned, vector has been retrofitted to implement all those guys. So the vector class, we can actually, if we're doing our refactoring in a step-by-step way, we can change the calls to our vector object to make them match like the clear and the add and all that razzmatazz. There's one other little thing too. You notice this angle bracket E. The original vector class didn't have this. So what this does is there's this idea of generics, and some classes are generic classes, and what that means is you can kind of declare them with a particular type in this spot, and then wherever you see in here, like where this says add E, it appends the specified element to the end of this vector. If I declare a vector, a vector of strings, I could put string in here, capital S-T-R-I-N-G, to say I want a collection of strings, and then if I do any adding or anything like that, if I use my add thing here, then it'll add. I can add string objects or .2D. In our case, we want to collect .2D objects, right? So what we can do, and that matches, how array list works. Okay. So before rather than just, trying to flip straight over to array list, a good step-by-step way to do this is first to try to convert our old usage of vector to the usage of vector that's been retrofitted to use the list to implement the list methods. All right, so let's do that. So the first thing we want to do is stick in our generic types here. So this is going to be a vector of 0.2d. Okay. Oh, actually we can just, since we declared it as 0.2d here, we can just use this diamond notation. This is just a less than sign, greater than sign, like that, or angle brackets, however you want to call them. And so now that's all set. Now, one of the nice things about doing things this way is that, I think I mentioned this earlier, we don't have to do any casting here. So let's get rid of that casting right now. If I do a find vertices dot. Okay, so we have our remove all elements. I want to go straight to where the casting is, because that's something that I can easily forget. Here it is. Okay, so see where we have this cast of 0.2d. So one of the advantages of these generics is that generic classes, you don't have to do any casting, because we know, because we declared vertices as being a collection of 0.2d, then we don't have to do anything special to say, hey, these are 0.2d objects later on. I think that's the only place. Oh, I should have done a search on like this, right? 0.2d. No. Okay. So yeah, so it looks like we got all of those. So now we got rid of the casting. Let's just double check that I didn't break anything with that. Okay, boink. And okay, so that looks okay. And then and then we just kind of want to go through step by step and replace all of those calls here. So remove all elements. The list version of that method is clear, so we should be able to say clear. And next one, size stays the same. Add element got replaced with just plain old add. Size. Element at got replaced with get. Element at get. Okay. So let's see if that worked. Yeah, looks like we're good. And then the last thing then is to make it, instead of making it a type vector, I'm going to make it an array list. And I think that's the only place. Yeah. Okay. Another thing that's nice here is the word vector really has a special mathematical meaning. So it's better not to even be confounding things with using something called a vector in here. So let's just make sure we didn't break anything with that. Hey. Okay, looks like we're good. So now we have no longer have an obsolete. If you want to read more about generics too, there's stuff on it on the on the Oracle site. So one of the things that's nice about it, so stronger type checks at compile time. So if I, for example, tried to get a string off of this list, right away I'm going to get a complaint from the compiler saying, nah, you can't do that. You know, so, or if I tried to add, you know, the wrong thing or something like that, I get automatic, you know, compile time checking. So that's pretty handy. You don't have to do casting, which we mentioned before. Okay, and then it's a nice little thing if you're actually implementing a class with generic types. There are advantages for programmers for that. But anyway, so that's a nice little cleanup that we did, and you know, hopefully we understand a little bit better about what's going on, what this is, that it's a collection of vertices, and that we're kind of collecting the vertices in the mouse pressed method of our anonymous, you know, mouse adapter class, and we are then pulling those vertices out, pulling those individual vertices out of our vertices collection in the paint object to paint them.